Mr. Harris here, and welcome to a new video. Here we're going to continue talking about metals, and in this video we're going to learn how we can extract the metals. So in the previous video we learned that different metals, they would have their different reactivities. Some of them are easier to be extracted, some of them are more difficult. So for physical methods, this is primarily for the less reactive metals. And for chemical methods, there are two. The first one is carbon reduction, which we will learn in this unit. And actually, there is another one, which is electrolysis, which you'll learn more if you take senior form chemistry. But I did talk about it in a bit in the first video. And also, you may be wondering, sir, like how do we know which metals they are able to undergo physical method of like panning, or which ones are going to do carbon reduction, which ones are going to do electrolysis? So there's actually a list, a series. We call it the metal reactive series. So it goes by like you have on the top, you have potassium, sodium, calcium, aluminium. All right, these are the top four. These will be extracted by electrolysis. Then you have a bunch of others like zinc, iron, lead, copper. Now, these would be primarily extracted by carbon, so what we call carbon reduction. And finally, we have the last group, which is silver and gold. So these will be extracted by the physical methods that we were talking about, or usually we would also just heat it by themselves. So this one here would be carbon reduction. These four: zinc, iron, lead, copper. And the top four, these would be by electrolysis. Okay, but this is just for your information. This is what actually we refer to know which metals are able to be extracted by which. So here, the top four here, these are the more reactive metals. The ones in the middle, that's what we were talking about last lesson about the moderately reactive metals, and these ones at the end, the silver and the gold, these are the less reactive metals. And we'll just be doing panning, or we can just simply heat it up and we can extract that metal. So let's see. So as I said, for gold or silver, for gold we have a physical method called gold panning. So what it actually means is you're just separating some mud and sand so that you can remove them and get the gold. It's very simple. You can get, if you have like some gold nuggets, usually we call it gold nuggets, not chicken nuggets, but gold nuggets. So, or you can get some small samples or pieces of gold ores and put it in a pan of water. And then you shake the pan, so you're like twisting it or swirling it back and forth. And then, because the gold has a higher density, it's heavier, it will sink to the bottom. So it will go to the bottom, and those dust and dirt particles, they would come out, or they would spill out because they are having a lower density. So eventually, the gold will be left behind inside your pan, and there you go. You have the gold extracted. But also, you can do another way is you can get the ore and you can just heat it up. When you heat it up, only the gold is left behind. So you can also do that. And the other more complicated method, as I said, for some metals, they're not existing by elements, like you don't have a gold nugget, you don't have a gold ore, they will be in compounds. Like in the previous video, I mentioned bauxite. This is the ore used to extract aluminium, but it's not only having aluminium, it also has oxygen in it. So actually, it's called aluminium oxide. So we need to find a way to extract it, and we do it by chemical method. Now here, the chemical method we're going to talk about in this book is only carbon reduction. But for bauxite, actually, we need to do electrolysis. But how about for the other example that I mentioned, the other ore that we were talking about last lesson, which was hematite. Now for hematite, we can do carbon reduction, which we're going to talk about now. Oh, here it is. Hematite, it contains iron oxide. So you can see here, this is the ore, but the metal that comes out is iron. And oh, there are some other examples of ores here. Bauxite, there you go. This is aluminium oxide. It has aluminium and oxygen in it. So this ore, you can extract aluminium, but this one uses electrolysis. Calcite, it contains calcium carbonate. So this one is also using electrolysis. So the ore, you can extract the metal. Here, it contains copper sulfide chalcocite. chalcocite. Yeah, I guess that's what you call it. So here, this ore, you can get copper out. Now this one you will use carbon reduction. Carbon reduction. Because why are we using carbon reduction? Because copper is a moderately reactive metal. How do I know it? Remember the series that I showed you in the beginning of this video? It's because of that. So here, we can extract these metals by heating these ores. So the metal oxide is just the ores with carbon. Okay. So here, for example, we can do that for copper and iron because both of them are moderately reactive metals. So what actually happens is at high temperature, that means you're heating them up. Let's say, for example, this metal here, we're talking about copper. So I have copper oxide, for example. And you can see the copper here. This is copper, Cu, and this is, maybe I shouldn't use green. It's kind of difficult to see. I might use a darker color. Here, I'll use purple. So this is copper, and this is copper. So let's say this is copper. And you can see it's bonded to, oh, sorry. This is copper, and this is copper. The red or orange ones, those are copper. So you can see they are bonded to oxygen. And you see there's this carbon that's happily enjoying by itself. What happens is when you are heating them up, the copper sort of steals away the oxygen. So you can see the carbon, sorry, I'm saying copper. The carbon here, it steals away or it removes the oxygen from the metal. So here you have the copper left behind. In other words, you have copper extracted and the carbon joins together with the oxygen here. So why is it called reduction? It's because it's sort of, you can see the metal was first together, right? And then now it is reduced. You can see, you can sort of think of it, it's reduced in number. So it was here first, now it's just by itself. So that's why we call it carbon reduction, because we're using carbon to sort of reduce the metal oxide. But if you take chemistry, the word reduction has a different meaning to it. But right now, if you're just studying science, I think this also makes sense. So carbon dioxide is produced in this reaction. So let's say originally if I remove this metal, if I say this was copper, so what exactly is the reaction? I have copper oxide reacting with carbon. And what does it form? Remember, this arrow means it forms something. It would form our copper metal and our carbon dioxide. So there's actually a chemical reaction going on here. So that is a word equation. This is what we call a word equation. So a word equation means there are words. Obviously, you see there are words, and it's an equation where you see like a plus sign and an arrow. So you will need to use this word equation in your exam or in your workbook quite often. So let me give another example. So you can just replace this word metal with any other moderately reactive metal. Example, iron. So I can put iron oxide, it can react with carbon. You heat it up, you would get iron plus carbon dioxide. Or let's take another moderately reactive metal. Let's say we have lead. Okay, let's say I have lead. So let me remove the iron. So I have lead oxide plus carbon. It will form lead metal and carbon dioxide. So here, this is what it means by the metal being extracted. You have the metal formed. So some metals, such as copper and iron, can be extracted from their oxides by heating the oxides with carbon. And this process of extracting metals is called carbon reduction, and this is the chemical method that you've learned. And obviously, there's another one called electrolysis, but in this book, we're not learning it. And the physical method primarily is for gold, which is panning. All right, so that's a wrap for this video. I'll see you in the next one. Bye.